Hello. So today we are going to discuss one question called as find the minimum in a sorted rotated array. So in this question basically we'll be given one array which is rotated around some unknown pivot which we don't know, and we need to find the minimum element from that array. So by rotation I means that suppose there is one sorted array which is from 0 to 7. Now we have rotated this array around some unknown point which we don't know towards the left. So you can also assume that uh, like this array has been rotated towards the left by the three times. So if you rotate this array three times toward the right, you'll be getting this array. So you'll be given this sorted rotated array and you need to tell the minimum among them. So there are two variants of this. The one is the basic version, and the other version is a more generalized version in which the duplicate elements would also be there. So if in this array the duplicate would also be there, then it becomes a hard question according to Leetcode, but I can assure you it's not. So how to approach it? One simple solution is go from left to right and find the minimum element in that case, and it will work. So that is just like bullshit. So other solution is like we know that this array is somewhat rotated, but I mean it was actually earlier sorted. Now it has been rotated around some unknown pivot which we don't know. So definitely the one thing which comes to our mind is we need to search something, and the array was rotated and now it has been just rotated. So the one thing which comes to our mind is the boundary search, but standard boundary search won't work. So how we can go for the some modification to the boundary search to solve this question? So we can think of it something like this. Suppose the array is from a0 to a of n minus 1. So we directly go to the middle like the standard boundary search, and we will compare the middle with the last element. So why we are just comparing middle with the last? By the end of the algorithm we'll be able to understand why I'm saying this. So first to compare middle with the last element. Now if middle is lesser than the last element, it means our required smallest element would be onto the left of this. Why it is like that? See here. See, if the array was something like this way, which is from 0 to 6, so if you find the middle, it will be 3. Now if you see, if 3 is lesser than 6, then definitely the middle element would be toward the left hand side of the 3. So that's the first case. Other cases, if it was the case something like this way. So in this case, if you see, if you find the middle again in this, the middle would be 7. Now 7 is more than the last element. It means that we can clearly just say that all of these elements are not useful for us, because since this is more than this, it means our minimum element would be lie on to the right hand side of it. So that's the second case. Third case is if you find the middle element and the middle element value is same as the last element value. It means if the middle, from the middle till the last, if every element is same, it means that, because if middle is same as the last value, it means that definitely all of these locations would have been the same. So we can just, in that case, we can just decrement the value of high, and it would work that way. So the basic pseudocode which we can think of is you have to compare middle with last element. If middle element is lesser than the last element, it means element is in left of the middle. If middle is middle, by middle I means the middle value. If middle is more than the last element, it means our element is right of the middle, or it could be middle as well. Else if middle element is equal to the last element, in that case you just have to decrement the high, because it would definitely be not the last element. It would be on over towards the left. I mean, it should be towards the left. It cannot be the high, because anyway it is rotated in sorted array, right? So this will be the basic algorithm which we are going to focus on, and let's just write this same algorithm over to this hard question, because if it works for the duplicate, definitely it will works for the non-duplicate elements as well, right? So let's start. So we can just make low as 0, and we can make one high, which is going to point to this nums dot size -1. Now we can just say while this low is lesser than high, we have to find first nothing but middle. So middle, everybody knows, is going to be low plus high minus low by 2. Now as we say, first we need to check if this middle value, which is nums of this mid, if it is lesser than what if it is lesser than the last element. So the last element is nums of high, which we need to compare with the high. If this is lesser, it means our required element is towards the left. So in that case, we can just say end is equal to mid. That is the thing which we need to we are doing. So other thing is, else if we'll just check if this mid value, if it is more than the nums of high. In that case, definitely we need to, if the middle value is more than the high value, it means definitely it would be lie inside the right hand side of the array. Because if middle is more, see, if it was less, it must have been towards the left, otherwise it must have been towards the right of the middle. So we can just say low is equal to mid plus 1. And if it is a case that middle element is equal to the last element, in that case we just do high minus minus and we are done. So, and after this we'll be getting the index of the low, which is the index of the minimum element. So we can just return the nums of this low, and let's try to run and check how many errors we are getting. So okay, so it's not end for us, it is high. Yeah, so let's try to submit it. Yes, it is accepted. But one thing to note in this is very important. First, let's try to submit this same code over to the this question as well. And then one thing we need to note here is, so let's try to submit it. Yes, it is working. Of course, it should work. Okay, so the other thing in this question is, which we should understand is, uh, see, if all the elements are same, let's say all the elements are 1 1 1 1 1 1, something like this. So if all the elements are same, then in that case, if you have noticed, this algorithm can take order log n time, sorry, order n time. Why? Because it will find the middle element and then again compare with the last element, and then in the worst case it may go up to, it has to do n minus 1 comparisons, and it can take order of n time. So the other thing is, if it is taking order of n time in the worst case, then see, why it can take order of n time is because elements could be same in this. In the previous question, which was a medium question, the elements was all distant. Then we are sure that either we will go to the towards the left or towards the right. So there was no case in which we can just decrement the high and keep on doing the thing. So in this case, what would happen is, like after the first iteration, this one would be removed from our space, and then again this one would be removed from our search space, then this one, then this one, and so on and so forth. So basically it can take up to order of n time in the worst case, right? So if it is taking order of n time in the worst case, then why we are even doing all this? So if it has to take order of n time, so we can just go from left to right and find the minimum element as well. So instead of this, we can also do something like this max underscore element from, we need to find from begin, right? So even if we do this thing, it should work, right? One second. Okay, we need to find the minimum. Sorry. Yes, it is accepted. And if you notice one thing, that it is even taking the lesser time, because our earlier algorithm was taking 16 milliseconds because it was doing all that operations and just finding the middle, then again low, high, and so on. So now if you see, the runtime has been reduced to the value of half. So this is the question, and I don't know why they have put this question into hard. But the only thing that which I understood from this, why it should be hard, is they wanted to implement it not like, of course, this way. They wanted to implement it in the previous way, but that's also simple. So no worries, and I hope you understood this question. Okay, bye bye.